mathematics class. This class is for class 9 and the chapter that we are discussing is coordinate geometry, that is chapter number 19, and we are following the book that is Understanding ICC Mathematics by M.L. Agarwal. This class is in continuation to the previous class of chapter coordinate geometry, and we were doing exercise 19.4. Exercise 19.4 we are doing, and we have discussed or done up to the question number 13. Now next question I take question number 14, that because that is different. They say using distance formula show that points A is 3, 1, B and C. Point B is given 6, 4, and point C is given 8, 6. So you have to show that these points are collinear. Show that A, B, C are collinear. Now what is the meaning of collinear? Collinear points means all the points that are said to be collinear must be there in a straight line. Suppose I say a point A, B, C. So if I take 3 points A, B, C, and if they are collinear, means if they are in a straight lines, it means either AC can be written as AB plus BC, or BC can be written as B, or it can be something like this, or it can be something like this. B, C, A, C, A, B. Suppose I take 3 points that are collinear. Collinear means they are in a straight line. So either AB plus BC will be equal to AC, or BC can be written as CA plus AB, or AB can be written as BC plus AC. Now what is the meaning of this? If there are 3 points and they are collinear, means they are in a straight line. So out of these 3 points, any one point can be A or B or C. So this is what I have done. I have made the 3 lines. Either it will starting point will, first point will be A or B or C. Second point can be any one of them between B, C and A, and similarly third point will be A, B or C, any one of the points. So if I am taking A, B, C as 3 points in continuation, it means AB plus BC has to be equal to AC. So either this will be correct, or BC will be AC plus AB, or this will be correct, or the AB is equal to AC plus BC, either this will be correct. The overall gist of the meaning, or the meaning of the question is that sum of 2 distances must be equal to the third distance. This is one distance, this is one distance, this is one distance. So sum of any 2 distances or any 2 lengths or any 2 line segment must be equal to the third line segment. So this concept we are going to use here. Means what we are going to do, we will find the distance between AB, BC and CA, and we will see if the distance or length of one line segment is equal to sum of the lengths of the other line segment, then they are collinear, else they are not. So first of all, we will find AB. AB will be under root, let's say 3 minus 6 whole square. A is taken as x1 and x2. 3 minus 6 whole square plus 1 minus 4 whole square. So 3 minus 6 is minus 3 square is 9, plus 4 minus 3 square is 9. 9 and 9 is 18. 18 under root 18 means 9 2 is 18. It means 3 root 2 is the length of AB. Similarly, we will calculate BC. BC will be 6 minus 8 whole square plus 4 minus 6 whole square. 6 minus 8 is 2 square is 4. 4 minus 6 is minus 2. Minus 2 square is 4. 4 and 4, 8. 8 is equal to under root 8. 8 means 2 root 2. Now we will find CA in terms of when we talk about CA. So 8 minus 3. 8 minus 3 whole square plus x1 is 6 and y1 is 6 and y2 is 1. So 6 minus 1 whole square, the 8 minus 3, 5, 5 square is 25 and plus 6 minus 1, 5 square is 25 and 25. It means 50 under root 50. 50 means 5 root 2. You can see that this 5 root 2 is equal to the sum of these two line segments. 3 plus 2 is 5 root 2. So we can say that since CA is equal to AB plus BC, CA is how much? 5 root 2 and AB we are getting as 3 root 2 and BC we are getting as 2 root 2. So this comes out to be 5 root 2. It means since CA is equal to AB plus BC, CA is equal to AB plus BC, this condition is satisfied. It means that the points A, B and C are collinear. Collinear, or we can say they are in a straight line. Now we will move on to the next question, and that will be question number 19. Now question number 19, they say A point is 0, 3, B point is minus 2, A and C is minus 1, 4. They say that A, B, C are the vertices of right angled triangle at A. Means that there is a triangle ABC whose angle A is 90 degree given. Means we can draw a diagram something like this. Let us say this is a right angle triangle in which angle A is 90 degree. Other any side can be B, any vertex, and any vertex can be C. Now they say that the coordinates of A are 0, 3, B are minus 2, A and 3 is minus 1, 4. We have to find the value of a small a. Now we know that in a right angle triangle we can always apply Pythagoras theorem if we have to do anything with the sides. And here we need the length of AB, AC as well as BC. Now in a Pythagoras theorem we know that hypotenuse is square. So in this case this will be the BC will be the hypotenuse. We know that the hypotenuse square is always equal to the sum of the squares of other two sides. So we can say first point in triangle ABC, we can say that BC square is equal to AB square plus AC square by Pythagoras theorem. Now we have understood which concept we are going to apply. So this question becomes very easy. BC is this BC. It means you have to find out the length of the BC, and you know the formula is under root x2 minus x1 whole square plus y2 minus y1 whole square. This was the formula of the distance. So simply I am writing directly the formula. BC will be minus 2 minus means this I am taking as x1 y1, this I am taking as x2 y2 for BC. So x1 that is minus 2 minus x2 is minus 1. So minus of minus 1 whole square plus then y1 is a minus 4 whole square. This is your BC. BC square. So BC it's whole square. So later on I'll be writing whole square. So we can say this BC square is equal to AB square. Now we will find out AB. So AB x1 y1 this can be considered as, for AB this can be considered as x2 and y2. So minus 2 minus 0 in first case, minus 2 minus 0 whole square, x1 minus x2 whole square plus y1 is a minus y2 is 3 whole square, and this total is the value of AB. So we need AB square, so we will put AB square plus AC square. Now AC square will be AC. So we can take A as, now we can take coordinates of point A as x1, y1. So x1, that is 0 minus of -1 whole square, x1 minus x2 whole square plus y1 is 3 minus y2 is 4 whole square and its whole square. Now with this square, this root cancelled, with this square, this root cancelled, and this root cancelled by this square. Now what is left? Only to open the brackets with the formula either a plus b whole square or a minus b whole square. -2 and this is +1. -2 plus 1 is -1 and -1 square is always 1. 1 into 1 is 1 plus. This will be opened with the formula of a minus b whole square. So a square plus b square is 16 minus 2ab means minus 8a. 4 2s are 8a is equal to -2 whole square will be 4 plus a minus 3 whole square can be opened by a minus b whole square. So a square plus b square minus 2ab. 3 2s are 6ab and then plus minus and minus 1. 1 square is 1, again 1, and 3 minus 4 is -1, minus 1 square is again 1, so plus 1. So this is the, now we have to just solve. So a square and a square will cancel each other. 16 and 1, this comes out to be 17 minus 8a is equal to 4 and 9, 13, 14, 15. 15 minus 6a. Now this plus a goes to this side and 15 comes to this side. So 17 minus 15 is equal to 8a minus 6a. 8 minus 6 is 2a. 17 minus 15 is 2. Implies that value of a is equal to 2. This is the final value. This is how we are going to solve the questions. In earlier also we have studied or we have learned that we are understanding geometry with the means of algebra. So this is what we are using, all the concepts of the geometry about Pythagoras Theorem, right angle triangle, square, rhombus, parallelogram, but with the help of algebra this is all being calculated. So now we move on to the next question, that will be question number 21. Now next question I am taking is question number 21. They say P, Q, R, S. P coordinates are -2, 2, -1. Q is 3, 4. R is -2, 3. S is -3, -2. You have to show that this P, Q, R, S is a rhombus, but it is not a square. So for this we need to know the properties or the difference between the square and the rhombus. So in a rhombus also all the sides are equal. At the same time in the square also all the sides are equal. Or you can say if we prove that the adjacent sides either this and this or this and this are equal, then it will become a rhombus. Second point, in a square the diagonals are equal, but in a rhombus diagonals are not equal. So what are we going to do? If we show that the length of the diagonals SQ and PR is not equal, it means that it is not a square. It is a rhombus. So first of all we will find out the length of PQ. So this will be x1, y1, x2 and y2. So that will be under root x1 minus x2, 2 minus 3 whole square plus y1 is -1 minus 4 whole square. So this comes out to be 2 minus 3 is 1, 1 square is 1. 4 and 1 5, 5 square is 25. So this becomes out to be under root 26 is the length of PQ. Now we are going to find PS because adjacent side is PS. So P x1 y1, S will be x2 y2 in the second case. So that will be under root 2 minus of -3 whole square plus -1 and plus 2 whole square. So you can easily make out 2 plus 3 is 5 and here it was 5. Here it is 2 minus 3 is 1. Here minus 1 plus 2 is 1. So obviously it will become 2, 3, 5 square is 25 and plus 2 minus 1 is 1. 1 square is 1. So that is under root 26. It means you can see that the length of PQ is also root 6 and length of PS is also root 6. So we can say PQ is equal to PS is equal to under root 26 units. So 26 units, and PQ and PS are the adjacent sides. We have proved that the length of the adjacent sides of this diagram are equal. Therefore, we can say that all its sides are equal. Now to prove that it is a rhombus, we will check whether SQ and PR are equal or not. So in the next case, we will find XQ, diagonal. You can write diagonal SQ. SQ. Now, when we are taking S, so we will be taking x1, y1 as X, x1, y1 as S, and Q will be considered as x2, y2. So minus 3 and plus 3, we can write it as minus 3 plus 3 whole square, plus y1 is minus 2 and minus 4. So minus 2 minus 4 whole square. So minus 3 plus 3 is 0, 0 square is 0 itself, plus 2 minus 2 and minus 4 is minus 6 square is 36. So it comes out to be 6 units. Length of diagonal SQ comes out to be 6 units. Now we will find out the length of diagonal PR. P will be considered as x1, y1 and R will be considered as x2, y2, because we are starting with point PR. So P x1, y1 and R x2, y2. Now 2 minus of minus 2. 2 minus and of minus 2, it means plus 2, its whole square. Then plus y1 is minus 1 and minus 3. Minus 1 and minus 3 whole square. So 2 and 2 is 4, 4 square is 16, and minus 3 and minus 1 is again minus 4 square is 16. 16 and 16 is 32 under root 32. 32 means 16 twos are. It means 4 root 2 units is the length of other diagonal. What we can say, we have seen that the adjacent sides of this diagram are equal. At the same time, the length of the diagonals is not equal. We can say that diagonal SQ is not equal to diagonal PR. Therefore, PQRS is a rhombus. What we were supposed to prove? We were supposed to prove that PQRS is a rhombus and not a square. If it would have been a square, then the length of the diagonal SQ and PR, the value of these diagonals would have been same. If this is 6, this has to be 6. Or if this was 4 root 2, this would have been 4 root 2. But since the length of the diagonals is not equal, it means this is a rhombus, because it is a quadrilateral whose adjacent sides are equal. That is one thing that we have proved. And second, diagonals are not equal, therefore it is a rhombus. Now the next thing they say, find the area of the rhombus. So we all know that area of the rhombus is half into diagonal 1 into diagonal 2. This we have not done. This is a part of mensuration that we'll be doing later on. But for your reference, I am just telling you that area of the rhombus is written as area of rhombus is equal to half into diagonal 1 into diagonal 2 always. Half into d1 into d2, that is the area of the rhombus. Half d1 d2, that is the area of the rhombus. So half diagonal 1 is 6 units and the other diagonal is 4 root 2 units. 4 under root 2 units. So 2 3s are 6, 3 4s are 12. Root 2 unit square is the area of the rhombus. So this is the solution for 21st question. Now we move on to the last one. Let's see what is there in question number 24. there is a small calculation error in finding SQ. Now SQ minus 3 and minus 3. So here it should come minus. By mistake I wrote plus. So minus 3 and minus 3 is means minus 6. Minus 6 square is 36. So 36 plus 36 is 72 units in root. Now 72 units in root means 36 to the 70, so 72. So this can be written as 6 under root 2 units. Now instead of 6 I have to write 6 root 2 units. So root, this is 6 under root 2 into 4 under root 2 upon 2. So 6 into 4 is 24. Root 2 into root 2 becomes 2 upon 2. 2 and 2 will cancel. So final this value will come as 24 units. 3 4s are 12, 2s are 24. 24 unit square is the length of the rhombus. Now we move on to question number 24. Next question, question number 24 is find the coordinates of the circumcenter of a triangle whose coordinates are given. Coordinates are, let us say, 8, 6, first coordinate, second is 8, minus 2, second coordinate, and third is 2, minus 2, that is A, B and C. We have to find the circumcenter. So let O be the circumcenter. Circumcenter means OA and OB and OC will be the radius. How is circumcenter formed? When there are 3 points, 1, 2, 3 points. So the point which lies on the perpendicular bisector is the circumcenter, and this is the radius. So with this we draw, with the radius we draw a circle. So this point is the circumcenter. So here we can say we have taken that let O be the circumcenter of the triangle. We have taken that O be the circumcenter of the triangle. Now in order to find, means OA is the radius here, OB is also the radius, and OC is also the radius. And since all OA, OB, OC are the radius, it means we can say that OA is equal to OB is equal to OC is equal to radius. So what we will do, first we will equate OA and OB, then we will see what we can write. Means we need at least 2 equations because there are 2 variables x and y to solve. So first we can say when OA is equal to OB, what we are doing, we are taking OA as R and OB as R. Both of them have to be equal. So OA, x minus 8 whole square plus square is equal to OB. That will be x minus 8 whole square plus y minus of minuses plus 2 whole square. Now we can see x minus 8 and x minus 8 whole square are there. So we can directly cancel them because one of them is going to the other side, that will become negative and all that. And since it was in the roots, so first of all we have cancelled the roots by squaring both the sides. So we are left with x minus 8 whole square plus y minus 6 whole square is equal to x minus 8 whole square plus y plus 2 whole square. So x minus 8 whole square, x minus 8 whole square cancelled because any one of them is going to the other side of the equal to, they will get cancelled. So when we open it, when you open the square, we will get y square plus 36 minus 12y is equal to y square plus 4 plus 4y. Y square cancelled. 36 minus 4 is 6 minus 4 to 32, and 12 goes to that side is equal to 16y, implies that y is equal to 2. Means the ordinate of this point O, the ordinate of this point O, we have got 2, or we have got the value of y as 2. Now we have to find out the value of x. So OA is equal to OB once we have taken. Now we can take OA is equal to OC because both of them are radius. This is also radius. Now OA is under root x minus 8 whole square plus y minus OA. Now in this case, okay, OA was same. OA was x minus 8 whole square plus y minus 6 whole square is equal to OC. O will be x minus 2. X minus 2 whole square plus y, and minus of minus 2 means plus 2 whole square. Root and root cancelled because we have squared both the sides, taking like that. Now we open it. So in the first case it will be a square plus 8 square is 64 minus 8 to the 16x plus y square plus 6 square is 36 minus 6 to the 12y is equal to a square plus b square minus 2ab. So a square plus b square minus 2ab, again plus a square plus b square plus 2ab, y square plus 4 plus 2 to the 4y. Now here we can see y square cancelling and x square cancelling. Now 64 and 36 is 100. So this can be written as 100 minus 16x is 100 minus 16x and minus 12y is equal to 4 minus 4x, 4 and 4, 8. Okay, so we can write minus 4x plus 4y and minus plus 8. So this is the value. Now this is minus 4x, so this will cancel this and can be written as 12 minus 16 minus 12 is 4. Okay, now this is 4y, this can come this side, so I'm taking both 12x and 12y to the other side and bringing 8 to this side. So that will be 100 minus 8 is equal to 12x plus 12y plus 4y. Now 12x plus 12 and 4 is 16y is equal to 92. Now we already got the value of y as 2. So in this we are going to substitute the value of y. It means 92 is equal to 12x plus 16y means 16 into 2. 16 into 2 is 32. So 92 minus 32 is equal to 12x. It will become 60 is equal to 12x, implies that x is equal to 5. So the abscissa of this point is 5. So the coordinates of x and y will become 5, 2. This was the first part. And then they say also find the circumradius. Circumradius means either you find OC or you find OA or you find OB. All these three are the radius. So if we want to find the value of radius, let us put in any of the equation. So I will put it in equation number, let's say OA. So here I am trying to find out the radius. Radius is OA. OA is under root x. X is 5 minus 8 whole square plus y is 2. So 2 minus 6 whole square. 5 minus 8 is minus 3 square is 9 plus 2 minus 6 is 4 square is 16. So under root 25 and root of 25 is 5 units is the radius. That is the final value. So with this question we come to an end of this chapter, coordinate geometry. So next chapter that we'll be taking will be statistics. After statistics we will be taking mensuration and then trigonometry. So we come to an end with this class, and till we start with come up with the next class. Please revise, please study hard and stay blessed. Thank you all of you.